Physics broken, the silent revolution inside China's 2026 Xiaomi SU7. In the gleaming corridors of Xiaomi's secretive automotive labs on the outskirts of Beijing, a team of engineers, many poached from smartphone chip divisions, did something that legacy automakers in Detroit and Stuttgart still refuse to believe. They didn't just build an electric sedan, they rewrote the fundamental rules that have governed electric vehicle design for 2 decades. The year is 2026, and the machine they unleashed is the Xiaomi SU7 Max. On paper, it looks like another sleek Chinese EV. Under the skin, it is a declaration of war on Western physics. Traditional silicon is dead. 400-volt architectures are museum pieces, and the laws of thermodynamics, centrifugal force, and dielectric breakdown have been bent, if not outright shattered. Let's begin where the pain starts for every EV engineer: voltage. For years, the industry benchmark was 400 volts. Porsche pushed to 800 volts with the Taycan and called it revolutionary. Ford and GM are still congratulating themselves for inching toward 800-volt platforms while their inverters overheat and their charging curves sag. Xiaomi looked at those numbers and laughed. The SU7 Max runs a sustained, terrifying 897 volts. Not a peak spike, not a marketing exaggeration. A full system operating voltage that sits comfortably near the 900-volt threshold, once considered the domain of experimental aerospace prototypes and deep-sea power cables. To the casual driver, 897 volts simply means absurdly fast charging. 670 kilometers of CLTC range added in 15 minutes. To the physicist, it is a nightmare. Push nearly 900 volts through a vibrating, road-punished chassis filled with metal, wires, and humidity. And you are waging constant war against passion's law. At these potentials, electrons don't politely follow copper traces. They ionize the air itself, leaping across microscopic gaps to create plasma arcs that can vaporize microchips, or, electrocute passengers. The insulation required to contain that energy in a mass-produced sedan is the same engineering once reserved for satellite solar arrays and nuclear submarine cabling. Western firms have spent years trying to tame 800 volts without dielectric breakdown. Xiaomi simply scaled to 897 volts and engineered the containment around it. But voltage alone is useless without the brain to handle it. Enter the inverter, the component that converts battery DC into motor AC. For decades, the automotive world has relied on silicon-based insulated gate bipolar transistors, or IGBTs. Reliable, cheap, and good enough for 400-volt systems. At higher voltages and switching frequencies, however, silicon IGBTs bleed heat through joule heating. Efficiency drops, cooling systems balloon, range suffers. The SU7 Max doesn't use silicon IGBTs. It uses a full-domain silicon carbide, or SiC, architecture across every power electronic stage. SiC has a band gap 3 times wider than silicon. It can switch at higher frequencies with dramatically lower conduction and switching losses. Heat generation plummets. The inverter runs cooler, smaller, and more efficient even at sustained 897 volts. Legacy automakers are still qualifying SiC for niche applications. Xiaomi made it the default for an entire platform. The death of silicon is not coming. It has already happened in Beijing. Now consider the heart that beats at the end of those high-voltage cables, the hyper-engine V8s. Xiaomi named it like a combustion engine because the performance numbers sound like science fiction. Maximum rotational speed, 27,200 revolutions per minute. That is not a typo. Most production EV motors top out around 18,000 to 21,000 RPM. Porsche's Taycan Turbo GT spins at roughly 16,000 RPM in its 2-speed gearbox setup. The V8 laughs at those limits. To achieve 27,200 RPM without the rotor exploding under centrifugal force requires metallurgy that borders on black magic. The rotor must withstand stresses that would shred ordinary steel into shrapnel. Xiaomi's solution: proprietary carbon fiber reinforced sleeves, precision-balanced titanium alloys, and a stator winding geometry that maintains structural integrity at velocities once reserved for turbine engines. The motor delivers 578 horsepower and 635 newton-meters of peak torque from a single unit while maintaining 98.11% efficiency and a power density of 10.14 kilowatts per kilogram. In the tri-motor Ultra configuration, two V8 units pair with a V6 to produce 1,548 horsepower total, 0 to 100 kilometers per hour in under 2 seconds. Top speed limited only by tires, and it does this without the gearbox complexity that plagues lesser high-rev motors. Centrifugal force at 27,200 RPM is not forgiving. Every gram of imbalance becomes a wrecking ball. Every thermal expansion differential becomes a crack waiting to propagate. Xiaomi's engineers countered with active vibration damping, liquid cooling channels integrated directly into the rotor housing, and finite element analysis models run on supercomputers that would make NASA blush. The result is a motor that not only survives but thrives at speeds where traditional designs disintegrate. Western engineers still debate whether such RPM figures are even sustainable in mass production. Xiaomi is already shipping them. Speed is nothing without control in the air. The SU7 achieves a drag coefficient of 0.195 CD, the lowest ever recorded for a production sedan. That number is not marketing fluff. It's actually the product of obsessive aerodynamic witchcraft. The body is sculpted like a pebble dropped into a stream. Every curve, every flush door handle, every active grille shutter calculated through computational fluid dynamics to minimize separation bubbles and vortex drag. 17 carbon fiber components on the Ultra variant generate 285 kilograms of downforce at high speed without adding parasitic drag. Underbody diffusers, active rear wings, and even the LiDAR housing, shaped like a droplet, contribute. At 250 kilometers per hour, the car slices through atmosphere with less resistance than many hypercars. Legacy German sedans with 0.22 to 0.25 CD coefficients suddenly look prehistoric. Fluid dynamics textbooks will need updating. None of this performance matters if the battery turns into a flaming lithium candle. Thermal runaway, the chain reaction that turns a single cell failure into a fireball, has haunted EV designers since the first Tesla fires made headlines. Xiaomi's answer is cell-to-body, or CTB integration. The battery is not bolted under the floor. It is the floor. Battery cells are glued directly to the structural underbody, forming a single ultra-rigid sandwich that increases torsional stiffness by over 30% while lowering the center of gravity. Between and around the 165 individual cells sit aerospace-grade aerogel blankets, silica-based insulators so effective they are used on Mars rovers and rocket re-entry shields. These 165 aerogel pieces create a thermal firewall. Heat transfer is reduced to near zero. Even if one cell begins to overheat, the aerogel prevents propagation. No more runaway, no more panic recalls. The CTB pack also eliminates the traditional battery enclosure weight, freeing up cabin space and improving crash energy absorption. Western manufacturers are still experimenting with CTB in prototypes. Xiaomi put it into volume production years ahead of schedule. The cumulative effect is, honestly, breathtaking. The 2026 SU7 Max delivers 835 km CLTC range on the 897-volt variant, 902 km on the 752-volt Pro, and charging curves that make Tesla superchargers look, well, leisurely. It undercuts Western pricing while delivering superior range, speed, and structural integrity. Legacy automakers, still wrestling with 400-volt carryovers, silicon IGBT thermal throttling, and incremental 0.22 seed body kits. Watch from the sidelines. Ford's Mustang Mach-E, GM's Ultium platform, even Volkswagen's MEB architecture suddenly feel like yesterday's news. This is not just an EV, it is a physics lesson delivered at 897 volts. A smartphone company that decided the laws of electromagnetism and material science were negotiable. A machine that defeats Joule heating with SiC, centrifugal force with hyper-engineered rotors, aerodynamic drag with computational sorcery, and thermal runaway with aerogel armor. The West spent 15 years patting itself on the back for disrupting the internal combustion engine. China spent 5 years rewriting the entire rulebook. As the SU7 Max glides silently out of the factory gates in 2026, its 27,200 RPM motors humming at idle, its 0.195 seated body slicing the air, its CTB aerogel battery pack humming with 900-volt potential, one truth echoes louder than the electric whine. The revolution is not coming. It is already here. And it was built in China. The question is no longer whether the West can catch up. The question is whether it still believes the old physics still apply.